Hello, everyone. My name is Deus Kandamali. Now, welcome back to the YES Lab training. Okay, this is actually machine learning training. In the previous video, we did discuss, the iris datasets. So we worked on the datasets that was built in from the scikit-learn library, and we use load digits and load iris. Also, we use load breast. All of these datasets. We went a little bit deep in the load iris, where we actually saw what was happening and everything that was actually behind it. So if you haven't watched that video, I would recommend that you go back to this channel and watch the previous video. All right. So in today's video, you're going to try something different. It's called, data processing with pandas. Okay. Now, data processing or data analysis, it is a very important step when you're doing classification or regression in machine learning, simply because it offers a lot of advantages towards attaining the best results. So now, why do we need this data processing or data analysis? Well, first of all, it's because remember the previous class, we worked, as I said, we worked with the iris datasets that was built in from the scikit-learn. And if it was built from the scikit-learn, all the data that are built in from the scikit-learn have been already pre-processed, okay? So you don't have to worry and bother so much about it. You don't have any missing values. You don't have to worry about repeating values. And so about any other irregularities, okay? But this may not always be the case. Like in the data that you might, you might come across when you're working with your different, machine learning problems, it might be very noisy, and this is a very, very important step. In order for you to do so, there are so many powerful tools, but I'll just go with the most popular, which is Pandas and NumPy and probably SciPy. So, for the sake of this lecture, we're going to discuss Pandas, okay? But talking about Panda without talking about NumPy, this is very, very difficult. So we're going to speak a little bit and just see how NumPy works. But all in all, I'm going to recommend that you use Pandas because the advantages that it brings over the table, okay? But actually it depends on the nature of your data. As you remember, the previous class, we didn't use actually Pandas at all. So Pandas at first is actually built on top of NumPy. So you should understand that they are both very powerful, okay? And they are both open source. So which makes them the best tools for your machine learning problem. Okay, now Pandas usually arranges your data in terms of arrays, okay? And the most, powerful object inside is called array, okay? So you're going to deal with data in terms of arrays, multi-dimensional arrays, and it's very fast in processing arrays. But for the case of Pandas, actually it works with the data in tabular form. So while NumPy works with data in numerical form, if you have numerical data, and this one actually works with data in tabular form. So now, in Pandas, you have very, useful, powerful objects called the data frame, also Pandas series. Okay, but for this class, we're going to use, the Pandas data frame. So you will see the way you're working with your data, which one suits you the most, okay? Plus, Pandas is very, powerful. It can work with so many data. If like you have data with so many rows, like the number of rows are from maybe 500,000 and beyond. So automatically Pandas is a very, beautiful and powerful tool. But if you're working with the less data, no, sorry, not beyond, like your data is up to 500,000 rows. So this is actually a very powerful tool to use. Okay. Okay, so let's just jump into our code. So the programming part, we'll start by importing all of them. So for now, we'll just importing useful libraries. So import Pandas SPD. Just use the default. Okay, import NumPy as NP. This one is already fine. Now, let's just start by creating a very simple data set and see the way these things differ. Okay, so create a dummy, okay, data set. Let's say you have For NumPy, it is just something like this. Okay, so you have my data one. Let's use this as NumPy. So it's NumPy array. Let's put any array here. You can just put values like these values. Okay. And then just run it. And then I'll just copy this one and repeat it. Data set 1. Okay, data set 2. That's set 3. So just change this one. My data 2. Okay, so suppose you have 3 different data sets. Okay, so this is actually a NumPy data. I'll just say, if we run this one, try to print the type. If we just check the type for this data. Okay, so the type is going to be type for my data. Type for my data 1 will be something like this. Okay, so it's a NumPy data, right? Okay, it's just an array. And now, in this case, okay, let's actually delete this one and put a Pandas data set. So I'll say my data 2. I'll say this one is a Pandas data set. So Pandas, as I say, I mean, for NumPy, we have array objects, but I mean, for Pandas, we have a very, two powerful objects. They are very popular. The Pandas series, and the Pandas series, as well as the Pandas data frame. Okay, so let's start with the Pandas series. So a series is actually like an indexed array. Okay, so it's very similar. So here, I'll just take the previous data, my data 1. I'll pass my data 1 here. I just want to convert this data here into a Pandas series. This NumPy data into a Pandas series. So here, I want to display my data, print my data after that. This is so that you see how these things works and how they look like. Okay, so here you have seen the array that we actually created here. So as I said, the NumPy actually works with the data in form of array. But now if we just come here, we'll see something different, a little bit different. Okay, so let's print the type first. So the type for this data, okay, my data 2, run it. So this is the Pandas series data set, and that's what we want. That's what we created. Now, if we display this one, we'll see a little bit of differences in terms of how they look like. So I'll just pass here my data 2. Okay, my data 2 here. I'll display it. So you see, this is an array, but now you have indexes. So a series is just an array that is indexed already. Okay, all right. Now let's go to a Pandas data frame. So I'll say, okay, I want to convert that one into a Pandas data frame. I'll be very careful and write these functions because they are case sensitive. So if you're missing anything, you might get an error. Okay, so here we'll pass. I want to pass the very same object here, which is my data 1. So I'll just write here my data 1. Okay, this run is okay. Just print, check the type. And checking the type, you don't have to print it. You can just check the type by just writing type and then just passing the object. But I like to print. Okay, so the type. All right. It's my data 2, my data 3. Sorry. So say this is actually a Pandas data frame. Okay. Now The pandas, as I say, the data frame, I mean, will just put you in terms of, I mean, in terms of a table with rows and columns. And this is exactly what's going to happen. So I'll just type here my data free, see how it works. Okay, so you have something like this, okay? Now, by default, the index for the columns, I mean, these columns is just column number 0. So if you just add as much columns, you just find something different. So the way they look, you can see this one is a table with rows and columns, okay? Because we didn't put as much rows and columns, so it just takes, I mean, like a 0, 0, we refer to this one because we don't have any rows and columns here we have created. So by default, you have 4 rows, 5 rows, okay? Because they start from the index 0. And I mean 1 column. In this case, this is the index. You see the differences. The 0 here for a Panda data frame starts at the first element, okay, which tells you that, I mean, it tells you that, I mean, this is actually, I mean, column 0, row 0, or 0, comma 0. But this one here, it just goes straight with the indexes, okay? So this is a Panda series, and this is actually a NumPy. So now, let's just do something different, okay? Now we're going to create, let's create a list, I mean a nested list, and see how it works, or a dictionary. We can just come with any object. So creating, I mean, let's create a dictionary, okay? If you don't know how to create a dictionary, I would recommend that you study Python, I mean, especially the class provided by Dr. Telemala, because he has covered all these basics in creating dictionaries and other tools. Okay, so the dictionary, I'll just call my dictionary data. Okay, all right. So this, don't confuse this. What I just showed you is how they look like. So now let's create a dictionary and analyze a bit more. Okay, all right. So now you have your data. So the dictionary will be something like this. Now let's say the first one you have. Let's say you have names. These are the names. And then names, you specify the names as an array of string of names. I'll just say Joseph as the first name. I'll go to another name. I'll just say Julius. I can go to another name. I call it, I mean, Rehema. Let's put a little bit more names. All right, here can be Anna. And then you have other names like Christian. Okay, 5 names, I think that should be enough. Okay, so that was first one. The second, let's go with their ages. You say ages. Okay. So here, I'll just put some random ages. So, okay, there should be integers, not strings. Let's have random ages. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this one. Okay. All right. Let's specify the year sex. Now this will be for sex. Just put an array here. Their sex, put characters. So the first one, Joseph, should be a male. And Julius should be also a male. Rema should be a female. All right. Okay, another female. And Christian should be a male. Okay, so we have 3 columns with names and ages. Maybe we can add another column for maybe their grades or maybe anything, or maybe their nationality. Okay. So I'll come back here, say another array here. Okay, maybe this one is Tanzanian, comma, then you have Kenyan, maybe you have Ugandan, and then you have another Tanzanian. So you have 4 guys. And then the last one, let's just take him. Okay. So the last one should be Kenyan. Okay. So you have some like this. Okay, let me run this, see if I just wrote it correctly. I believe it's correct. So now let's analyze. This is just a dictionary, okay? So for now, if you just type, if you check the type for this data object, because it's data here, so I'm just printing here, sorry. I'm printing the type, sorry, of the object I just created and run it. It says it's a dictionary, okay? So this is actually a dictionary. So now if we display this dictionary here, you see the way it looks. So I'll print this dictionary, print data, see how it looks. Okay, looks like this. Shows you have names, a couple of names, ages, nationality. So this actually looks great, but it doesn't look as good as it should be, because if you're going to analyze something, you have to see it in a way, in a proper way, okay? All right. So if we can convert this one into either a NumPy, it depends on what you want to work with. As I said, for me, I like to work with Pandas because for me, Pandas is actually, very useful, and for me, it's very interactive. So I just like use Pandas. But you can, let's say we convert this one into a NumPy. So this data, we're going to pass it into a NumPy. So NumPy, I'll say the resulting data will be NumPy data. Okay, so the NumPy data, I want you to take the NumPy array, because we're dealing with the array object in NumPys. Hope you remember that. And now we are, instead, if you remember, okay, let me take you back. If you remember at the top here, we created our own array, you see? So we did put these square brackets, and then inside we just put these arrays. You remember that, okay? So now we don't put the elements there, but rather we're going to pass this object here, this dictionary here, that you want to create into an array. So I'll say create NumPy here. Now, if I come and I check the type, let me use this same cell. If I check the type here, okay, if I check the type here, it's and data and run it. It says now it is an array. Okay, now let's display it, see how it works and how it looks as an NumPy and data. Okay, not very different. I think it's the same. Okay, it's fine. Now, what if we convert this into a series? Let's try to do that. Okay, I don't know how you can do that. Now, I would recommend that whatever I'm doing right now, you just you grab your computer, or of course I believe you have your computer now. Now you just grab your Jupyter notebook and just go along with me, okay? So that you just you're not missing anything. All right, yeah, you just use you code, you put hands-on skills. This helps you understand even better. So right now I'm going to do the same thing. I'm going to do the same thing but using a Pandas series. So I'm going to say the resulting data should be maybe series data. You can use any variable names of your choice. Okay, it doesn't matter. So to me, I'll say, okay, it's a Pandas, but create a series. Remember, a series is a capital S. Okay, so a series, and then I'll pass that data here, because in the first step we created, a NumPy. So now we're going to create something different. It's a series. So now I'll say I put data series there and then run it. Do you have any problems? No problems. Okay, great. Okay, so now let's check the type. Should be series. The type for is data. This should be a series, no doubt. Okay, it's a series. Now let's print, see how it looks. Okay, so this is a series object from the pandas. Now, will it look the same as NumPy? I know it won't. Okay, let's just see. Okay, so now this looks a little bit different because you have the names as your indices, and then you have, these are the names, ages, sorry, and sex, nationality, and so forth. So it displays something like, which is great, but it's not very visible. Like, for instance, if it's not very easy for someone just who hasn't created this to know that Joseph actually has 20 years because they are not even aligned. Okay. Okay. So now let's create a pandas, data frame. Okay. So I'll say data frame, df for data. Okay. So for data frame, if you're going to create pd dot data frame, start with the capital D, data frame, and then pass in the data inside here. And then go on, print the type. This is the same thing that we did before. So right here, I'll pass data frame data. Okay, let's display. It tells you that this is actually the pandas data frame. Let's display, see how it looks. Okay, so print the df data. Okay, so this is actually how it looks. This looks a little bit interesting, you see, because it's very visible. Okay, so you have default indexes here. You have the columns. Okay, so in the column, in the names column, you have all these 5 columns. In the ages, you have sex, nationality, and so forth. So at this point now, you can see the differences on how they look, on how your data will look like. As I said before, pandas likes to, works with data in tabular form, while this one works with data like, in array format. So this one is actually for me very useful because I can see my data, and if there are so many data, it's very easy to look at them and analyze and see how, and easy to understand them, even if it's a new data. Okay, so that's the first step. Now, the second step, let's see what you can do with this, pandas data frame. Okay, so what we can basically do with the pandas data frame. So now let's come here. I'll just cut here to the original data. I'll try to add some other data, some other items. Like in the name here, I can add somebody else. Let's call him maybe Isaac. But for the age, I'll try to put a missing value in the age. So by putting missing value, I can use this, NP, because NumPy has, this function that can actually do that for you. It's called .nan. So this was an NAN set for not a number. So if I say this, then you just put something like not a number. This is actually what we call a missing value, okay? And then maybe I can say here that we don't have a number. NP dot not a number. And then here, I'll just add the nationality. So the nationality can be maybe, I'll just say Rwandese. So we have other one these here but we don't know their ages or their sex. Okay, I'll have to run here, run all cells. Okay, so if you can come here with the data in your data, you'll see, for instance, you'll see in your NumPy, you'll see this one. It's an added, not a number. Run these, you have another number here, and then you have a not a number here, not a number here. If this confuses you, I recommend that you just write it from the beginning and you add this, okay, so it doesn't confuse you. But there is nothing fancy about it. No, but if you analyze your data, as I said, as a data frame, this works very great because it's very much visible and you can just spot it here. Like you have this guy here called Isaac, but their ages, you don't know their age because it's not specified, and the sex is actually not specified. This is what we call a missing value. These are what we call missing values. Now, you might ask yourself, if you have been given a data set that is a very huge file, like with so many rows, it's not very easy to spot that by your naked eyes, okay? So for instance, because we have actually, a very small data set, it's very easy for us to observe that you have some missing values. But how do you actually check for missing values? Okay, that's the rest. All right, so now, Pandas data frame offers you tools to do that. Okay, so how do you do that? You can just say df data, okay? Because it's a data frame, make sure you use that data frame, okay? Don't use the other object because you might get an error. So data frame, you can use what we call is null beating method. Okay, if I use is null and then I run it, this is the kind of table that I get. It's similar to this table, but actually this one is a Boolean method. It returns a Boolean value, whether there is or there isn't. But if it says false, it means there are no missing value. But if it says true, it means there is a missing value, okay? So here it says in the first column, okay, false means the first column, the first row, it's false because there is no missing, but there is a value. Actually, a value is called Joseph. So there are no missing values here. In Julius, there is no missing value here. The same applies. Now we know our missing value is here in the ages and in the row number 5. So if you come here, you'll see true, and this is actually true for the sex column, which tells you that in our whole data sets, we have 2 missing values. So this gave us a picture of, like, in all data sets, what are the missing values, if any, okay? But remember, this just, displayed the missing values in the whole table. If the table again is very big, you may not notice this one, okay? But if you want to go specifically, like for instance, I want to check in the specific column if there is a missing value or not, there is a way to do that, okay? So I'll just go down here. I'll say, okay, I'm going to say data dot is null. Sorry, you specify the column. Like I want to specify a column. So like in a specific column called the nationality, I know nationality doesn't have any missing value, right? Because they are all of them are listed here. So I'll just say in the last column. Now remember to write the column name specifically exactly as the way you wrote there. If you're not sure, you can just copy it and then paste it there, okay? So you don't have any errors. Let's see what this brings. And if you run it, it says false for all in rows. It means the whole rows, you don't have any missing value. You understand, okay? Now, this actually returned the whole, the whole column. You might want to just know whether there is or there isn't, but we'll just go back to that later. So let's just see. We know that there is a missing value in the ages and sex columns, okay? So if we just put them here, we're expecting it to be true now because we have one, okay? All right, so this is an operation like in logic. So, if one of them is true, then the whole value becomes true. So if I run it here, okay, it says there is false, 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 but there is a true somewhere here. I hope you can see it here. Okay. Okay. So now let's go and see if I want to just know whether where it exists or it doesn't. Because as I told you, if you have so many columns, you don't care like which, you have so many rows, like your dataset file is very big. You don't want to know where, if maybe most of the time you don't want, just want to know if there is or there isn't. So if you want to say that, you can add like, okay, I just want to know whether for the sex, column. Okay, let me start with from the first one. Names column exists a missing value or not. As I said, you remember the first one, it was false, like false for all cases, which means the answer should just be false. So you can say, I want you to check any missing values from all these, from the whole column, and it just goes and return false. It will return false because you don't have any missing value. Okay, now you can repeat this one for the rest of the columns. So I'll put a comma here and say, what about the ages? What about the ages column? So I'll just copy this one. And then I'll paste it here, right here. I'll put a space so that you can see. And then I'll put ages. So after running it, it says false, true, which means for this here expression here, it will return false, because in the names column, you have actually no missing values. But then for the ages, there is a missing value. It doesn't matter how many, but for as long as you have at least one missing value, you should just say there is a missing value. Okay. And then if you want to check for the rest, you can just add as much as you want. Now, I'll just display the same thing for sex, of which there is, it should be on true. And then let me see. Okay, it says false, false, true, false, true, true. So this is how we check the missing values in the as. Okay, let me remind you. Missing values, they are not good because they may just they may mess up with your model, the precision, the accuracy, and everything. So you might want to check and rectify that one. There are ways to do that, to rectify it, and we'll cover them later. But the first step is actually how to detect whether you have missing values. Now you have already seen that you can see a missing value from the whole table. If you want to check from the whole table, like your whole data sets, okay? But also you can specify a specific column, and exactly, if you just want the answer to be returned, whether there is or there isn't, you have seen the way to do so, okay? Now, apart from that, there is what we call a not null. So this is actually the opposite of this, of the is null. So the not null method is actually going to check whether it's not null. So it's kind of like the negation of the other one. So say df data, I'll come back here. Let me use the same. If I put names here and I say dot not null, it is going to print me the reverse. At the beginning, it was all false. Here, the names here were false in the names column, but now they're all true. It means it just reverses it. So you can use it like we just said here, and the rest of the columns is no problem. Okay, so now let's see what you can do with these missing values. So what you can do with the missing values actually is you can either replace them with the values of your choice, or you can decide that you drop them, or you can just use the mean or their mode or their median. It just depends on how it suits your data and when you're analyzing, see what works best, okay, in your data sets. All right, so now let's see how you can do that. All right, so you have in data. I'll just come back here. I'll say for my n data, not n data, I want to use df data. For my df data, okay. And then I'll say names. So this is the first column. Okay. You can use what we call filter method. Okay. Now filter method accepts, the value here. which value do you want to put in the names if you have any missing value. Okay, we don't have missing values in the name, sorry. So I'll have to go with the ages. Because we don't know the age, we can say, we can decide to drop. Okay, we can decide to drop. All right. So for instance, here, in this guy here, we can say that because you have missing values, we can decide to drop this whole column. That is something, this whole row. Or we can decide that we drop, we change, or we replace this value with any other value. Okay, so in the DF data here, I'll display the DF data here first. Okay, I'll display the DF data here. Okay. Again, so that we see it. And then I say, just right here above, you have missing values. So I'm going to change so that you see if we have already replaced it or not. Okay, so I can say the data frame. Okay, let's work with the data frame. The column, ages column, go to the ages column. So in this column, use the fill now. So this method will actually fill, our data set with the values. So I say if you just see this value, you can specify the value that you're going to fill with. So you might want to say value equals to 0. Let me run this. You see what he did here? He just take all these ages. These are the same ages like the ones that you see here. You see? But finally, he just put a 0 into our column, into our specific guy. So we just say this guy has actually 0 age. You see, it may not be true because you don't have a 0 age. It might not make sense here, but it depends on the data sets, okay? So if you have actually worked with the data sets, you know what you want to do, you can just put the value that you think it fits best there. And it doesn't have to be an integer, it can be any other value, okay? So it is something that you decide on your own what you want to put there, depends on the data. But also, you can put something like a mean, you see? So in other cases, you see, okay, for this case, let I use the mean. Okay, it may not be very suitable here because the ages, you cannot put, somebody's age on their, based on their mean, but you can just take the mean of this data here and then put it, and just the rest of the data and then put it here. It just works fine as well. So if you want to do that, you'll say, let's first find the mean. I'll just say mean, okay, mean of the data. Okay, let's not mess with this one. I'll just say mean of the data. Let's add another here. Put a mean here. I'll say mean. It should be, let's find a mean for that data. I'll say it's a data frame. Data. Then what is the mean? Is data ages. Then find the mean. Okay. Find the mean here. Let's print the mean if there isn't any. See if the mean, what is the mean? So the mean is 40. So this is the mean from here to here. Okay, so this is the mean for the first, the ages for the first 5 students or 5 people. Okay, so just take that mean and then you add it. So come here, I'll copy this one. I'll go down here. I'll just paste it here. I'll say, okay. Now, what I'm filling now, I'm not filling this value, but rather I'm filling the mean. Okay. And here you go, you have 40. You see? So now, let's try to run all the cells. Okay. If you can notice that Isaac, the Isaac age still doesn't change. It's still the same, you see? And the reason why it doesn't change is because, however, we have already filled it. And the reason, I don't know if you can try and figure that out. Okay, but the reason why it doesn't change is because this is actually what we call an in-place function. Okay, okay, the changes have been made, but they have not been made to update the previous file. I mean, the previous data. So it did not affect the previous data. Now, if you want it to affect the previous data here, we'll have to specify by saying an in-place should be true. This is a Boolean, okay? Okay, so let's run this one. Now let's try to run all the cells. So you see now it's 40, it has been affected already. But if you put by default, it means it's false. And this is the same as writing that an in-place is what? Is false, sorry. I misspelled this one, is false. You know, if you say that an in-place is false, then if you run all of these, run all the above. You see, it comes back to them. You understand? All right. So if you want to affect your previous file, just you have to explicitly test. Specify that this one is actually in place. So I'll rerun this one, and then run all the above. Says 40. Okay. So you can decide to also change this person here into another data set. You can also you can work with that now. You know how to put. You can put the mean, or you can put the mode or the median. It just depends on what you want. So if, for instance, someone will just go and say, we're going to put a median here. That was a mean, say median or mode equals to df. See the ages dot mean more df ages dot mean, sorry, dot mod, sorry. Okay, so now I'll just print the mode. I don't want to print the median. I'll just say print the mode, or I could just print it afterwards, like mean, then print mode. Mode. Okay, let's print mode here so that you see clearly. Okay, so okay.